Hello everyone, welcome to a new video. Today we will look into ANOVA or Analysis of Variance test. It is a kind of a hypothesis test which is parametric in nature. The first pointer is it is parametric. The next is when would we use it? We would use ANOVA when we compare a continuous and a categorical variable. That is a continuous and categorical. By, by compare, I mean if we want to find the relationship between a continuous and a categorical variable. It is especially used when the categorical variable has multiple levels. This is important. So by multiple levels, what do we mean? If we take this example in which we want to see there are students and there are number of questions that the student has been able to answer, but under the influence of noise, that is under low noise, under medium noise, under high noise. We want to see if the level of noise, if it affects the ability of a student to perform or answer questions. So there is a categorical, there is a continuous variable, that is the number of questions answered, which is continuous in nature, and there is a categorical variable, that is the level of noise, low, medium, and high or loud. So we have a continuous variable and a categorical variable which has multiple levels, that is more than 2. Okay. There are a few this is as we said, this is a parametric test or parametric in nature. So there will be certain parameters like mean that we would need to use in the test. There are a few parameters that we'll use, or a few terms we would use. Where that is capital N, that will be the total number of sample. Over here it is 12 because there are 4 students in each class. So there are 3 classes or 3 categories. So there are 12. The total size of the sample is 12. Then there is a small n. What is that? That is basically the number of students or number of samples in each category. So over here there are 4, in each of the categories there are 4 students. So n is, small n is 4. There is k. What is k? K is the number of categories. There are 3 categories. So k is 3. We would need these 3 numbers in order to perform our test or calculations. Let us begin. The first calculation we will do is find the correction term. Which is equal to summation of x whole square by n. It is also denoted by Cx. So denoted by C subscript x. So summation of x whole square by n would be around something like this: 32 plus 25 plus 17 whole square by n being 12. That comes out to be 456.33. Is equals to Cx. How do we calculate the x, the summation of x? What is that? Basically, we are summing up the number of questions solved by the students under each category. We are adding it up: 10 plus 9 plus 6 plus 7, that comes out to be 32. Similarly, the next category comes to 25 and then 17. What is summation of x square? We are squaring these terms up and then adding it. Then there is a sum of squared total. also denoted by SST, sum of square totals. How do we calculate that? It's basically sum of x square minus Cx being the correction term. It is 266 plus 165 plus 77 minus Cx, which is 456.33, and it comes out to be around 51.76, which is the value of SST. We all use these calculations for the upcoming steps. The next is the sum of squares among group. It is summation of x whole square by n minus Cx. That comes out to be something like this. And over here n is 4. Summation of x square, we'll sum them up and then square it. Cx is this 456.33, and this value comes out to be 28.17. And this is denoted as SSA, sum of squares amongst groups. Next we have sum of squares but within group. That is SST minus SSA. And it is denoted by SSW. So the value of SST is 51.76. Value of SSA is 28.17, which comes out to be 23.5. This is the value of SSW. So we have these three values. Now how do we use these three values? We have a few more calculations. The first being the mean sum of squares amongst groups. Of squares among groups. That is SSA by k minus 1. And this is denoted by MSSA. So the value of SSA is 28.17 divided by k is 3 minus 1, that is 2, and it comes out to be 14.08. The next calculation is the mean sum of squares within group. Is denoted by MSSW. How do we calculate it? Basically SSW by n minus k. So what's the value of SSW? It's 23.5 by capital N being 12 and K being 3. And it comes out to be 2.61. This is the value of MSSW. The next step is to find the F ratio. How do we calculate it? It is basically MSSA by MSSW. So the value of MSSA is 14.08 divided by 2.61, which comes out to be 5.39. This is our value of F ratio. This is very important to us. Now we have two things over here. One is the N minus K. N minus K is known as the degree of freedom within groups. Degree of freedom within groups. And K minus 1 is similar degree of freedom among groups. Okay, so we have calculated both. Where do we use it? We have something called a F table, which looks something like this. So, in any test, we have taken the level of significance as 0.05. That is a norm, not a rule, but a norm. Now we saw that the degrees of freedom, right? So on top, as we go from left to right, that is the degree of freedom amongst groups. So in our case, the degree of freedoms amongst groups is 2. Whereas as we go down, we see the degree of freedom within groups. So in our case, the degree of freedom within group is 9. The n minus k, that is 12 minus 3 is 9. And k minus 1, that is 2, is our n minus k, that is 9, which is the degree of freedom within the group, and k minus 1, that is 2, that is degree of freedom amongst groups. So our corresponding F value for degree of freedom 2 and 9 is 4.26. Okay, so it is, as we see, it is 4.26 for degree of freedom 2 and 9 respectively. So for a level of significance of 0.05 and degrees of freedom, that is n minus k is 9 and k minus 1 is 2, and degrees of freedom 2 and 9, we see that the F tabular that we just saw from the table is 4.26. Our F calculated is 5.39. So, which is, and the our F calculated is greater than the F tabular. Now in any hypothesis test, we have two hypotheses, the null hypothesis and the alternate hypothesis. The null hypothesis states that there is no relationship. And the alternate hypothesis states that there is a relationship. Right? Now, if our F calculated is greater than the F tabular, in that case, we will reject the null hypothesis and accept the alternate hypothesis that there is a relation. But if our F calculated is less than the F tabular, In that case, we will accept the null hypothesis and reject the alternate. So in our case, since our F calculated is greater, F calculated is 5.39 and the F tabular is 4.26. So since our F calculated is greater than the F tabular, we are rejecting the null hypothesis and we are accepting the alternate hypothesis. So we can say that according to our example that we have, the sample, the noise level does affect the ability of a student to solve the problems. So this is our takeaway from the test. I hope you liked it. If you did, do not forget to like, share and subscribe. In the next video, we'll look into another hypothesis test followed by the Python implementation of these hypotheses.